Hello and welcome to a special Pearl Conference replay. This lesson was presented by Doug Powell, CEO of National Switchgear and past Pearl president. This was presented at the Pearl Conference in Greenville, South Carolina on April 14, 2018. It covers component inspection and evaluation and is titled Determining if a Component Can Be Reused. Doug's content has been created to an interactive format by Technical Sales and Consulting's Training to Go learning series. At the conclusion slide, you will have an opportunity to register for your certificate of completion. Now let's get started. Here's what we're going to cover today. Pearl has a very good 4-step evaluation process, and we'll examine this in detail. We will then get into what is the most effective inspection a Pearl technician can perform. And last, we'll look at 5 criteria that can be used in a Pearl inspection. In this part, we'll use an acronym to help you remember the process. The Pearl evaluation process is essential to helping determine if a component can be reused. Let's spend some time looking at it now. The 4-step procedure, broken down into visual, measuring, comparing and operational, and testing and documentation. In the first step, visual, you'll need to use all your senses. The inspection of electrical equipment by a qualified technician includes using vision, hearing, touch, and smell to gather data. The next step involves measuring and comparing values using a variety of electronic measuring sets such as a DLRO, multimeter, and insulation resistance testers. The third step, operational evaluation, is done through observation of repeated operations of the equipment. Finally, testing and documentation needs to be accomplished. It can be done by application of operational voltage and amperes to equipment and recording and comparing the results of the equipment. Now let's turn our attention to the inspecting process. The Pearl Inspect and Test Standard follows a 4-step process which includes inspection, cleaning, testing, and documentation. Today's presentation focuses on the critically important first step of this process, inspection. So what is inspection? By definition, a non-destructive examination method used to evaluate an item by observation. Dr. Joseph Aran, recognized as one of the giants of modern day's quality and who worked closely with others in the field of total quality management like Edward Deming and Philip Crosby in the mid-50s, wrote that based on the studies he performed on inspector accuracy, that 100% inspection is about 87% effective. The conclusion is that regardless of technological advancements in inspection techniques, the primary and most important inspection test technique is visual inspection. Time has proven that visual inspection is the most effective technique of all. Visual inspection should be the primary method, including an effective quality control program. It has been shown repeatedly that visual inspection conducted by properly trained inspectors results in the discovery of the vast majority of those defects which would only be discovered later by some more expensive non-destructive test method. For all of the quiz questions, click on your answer, then click on Submit to continue, and then follow the on-screen instructions. In the Pearl Inspection and Test Standard, it describes 5 types of defects that a trained qualified technician should be looking for when performing an inspection of any electrical component. Should they discover during the inspection that any of these 5 criteria exists, it should be a no-go for determining the reuse of the part. The SMART acronym is an easy way to remember the criteria. So let's go through them. S is for stress. Internal forces and age can cause materials to fatigue, often resulting in stress cracks, fractures, chips, and material deterioration. M is for missing items or parts. Missing or damaged parts, inspecting for missing, damaged, loose, inappropriate parts including signs of cross threads and strip threads. Alignment is the A. Warped, buckled, twisted, bent, or misshaped in some form. Alignment issues can cause fundamental circuit breaker operational problems that can often go unnoticed until a final assembly or in service. R is to look for rust. Deep-seated or corrosion extending far down from the surface could be signs of water, salt, or chemical damage. Rounding out the acronym is T for temperature. Extreme temperatures, such as what you would see in a breaker fault, can cause thermal stress to the materials. We will go through some illustrations to further reinforce the concept. Inspect for chips, cracks, and deterioration. You will find this phase repeated over and over in the inspection steps of the Pearl standard. Usually you will see them associated with pole bases and insulator phase barriers and arc chutes. Fatigue components can occur over time, creating cracks, especially with insulated parts. In the section on covering contacts, it says inspect for cracks, chips, and pitting. This photo shows a combination of these aspects, including deterioration and contact erosion. Notice the cracks on this secondary contact block. The electrical connections might be fine, but this condition could worsen and create a catastrophic problem with equipment damage and personnel injury. Let's test your inspection prowess. Can you spot the problem in this photo? Click in the area where you see the problem. That's correct. Stress cracks are visible on the toggle of this RD breaker. Therefore, the toggle should be replaced to ensure proper operation. The second Pearl inspection criteria is M for missing parts. You'll find this frequently repeated in the standard. It is important to inspect for damaged, loose, missing, and appropriate parts. This technique found in this particular phase is used about 14 times in just one standard for power circuit breakers. Now let's examine some examples. Take a look at this photo. Let's pause for a moment to see if you can determine the issue. Just because this nail might work as a cotter pin, it doesn't build confidence in your workmanship with your customer. Finding the loose parts is something more obvious than finding missing parts. This is why you should have a trained and qualified technician performing the inspections and disassembly of equipment. Here are examples of damaged control wiring and a damaged charging mechanism. The damaged insulation on the control wiring may not be as obvious, so careful inspection of all wiring is necessary. The charging mechanism is more apparent because of the broken plates. Both could cause major headaches for the user at a later point. The next point in the inspection process involves A for alignment. Warped, buckled, twisted, bent, or misshaped in some form, alignment issues can cause fundamental circuit breaker operation problems that can often go unnoticed until final assembly or when the breaker is in service. With alignment issues, you're looking for warped, buckled, twisted, bent, or misshaped in some form. Typically, you will be looking for this on metal frames, mechanism assemblies, and contact assemblies. Here are two examples. Can you spot the issues with them? Take a look and we'll pause the audio. You can see the obvious wear here. Also noted in this photo is the issue with the mechanism. This photo shows a pretty good example of a twisted part that needs to be replaced and discarded. You might also take some time to inspect the mating part to see if there is a reason why the part became twisted. The fourth inspection criteria you'll frequently find throughout the Pearl inspection standards is inspect for rust and corrosion. Deep-seated rust and corrosion extended far down from the surface could be signs of water, salt, or chemical damage. If you're going to perform a complete rebuild of a unit, most surface rust can be removed during the cleaning process. But if you're just doing an inspection and test, the unit needs to be rust and corrosion free. Rust on non-electrical parts like enclosures does not always prevent proper operation. Many plants have moisture in the air that cause surface rust. What we're looking for is deep-seated rust and corrosion like you see in this mechanism. This could be a sign of water, salt, or chemical damage which can severely impact the opening and closing operation and speed of this unit. A unit like this would require replacement parts and a total disassembly and rebuilding, probably not cost effective to rebuild and obviously not a candidate for inspection and test. As you can see in this image, the roller bearing assembly is badly showing signs of rust. Always replace bearings and rollers covered with surface rust that have any pitting. Particles may be introduced into the rollers and interfere with the ability to form a proper fluid wedge. The last inspection criteria found frequently throughout the Pearl standards is temperature inspection. Extreme temperatures such as a breaker fault or overload can cause thermal stress to materials. Typical areas to look for this type of material damage is around all current carrying parts, the breaker frame, pole bases, and primary and secondary disconnects. Here are some typical examples of temperature issues. Can you spot them? We will pause again to give you time to examine these images. Look for signs of burnt residue and signs of extreme temperature that is not natural. These items were exposed to the most extreme heat conditions, such as an arc flash. In many cases, these signs are the result of a breaker clearing a fault. Typically, arc chutes show this excess temperature. Another area to examine is all insulation traces of burn. All of the affected items shown required replacement. Arc chutes, contacts, contact springs, and disconnects can all experience extreme temperatures during normal interrupting operations. These components should be carefully inspected for signs of overheating and deteriorated insulation. These components should never be reused when performing a basis of inspect and test. Here is a summary of what we covered in this session. First, we looked at the Pearl 4-step evaluation process. This included inspection, measuring and comparing, operational, and testing and documentation. Next, we discussed the most important tool a trained and qualified technician has, and that is inspection. Lastly, we described the acronym SMART. The S was for stress cracks. The M was for missing parts, the A covered alignment issues, the R stood for rust, and finally the T was for temperature. We hope this provided a basis to help determine if a component can be reused. Here are your quiz results. Please note your score and record it. You will need to transmit this score when completing your request for the certificate of completion. If the score is below the passing grade, you may retake the course and complete the quiz questions. If you receive the passing grade, please note the score and continue the conclusion slide by hitting the Tab key. This completed Component Inspection and Evaluation Training, a replay of a training session presented by Doug Powell at the Pearl Conference in Greenville, South Carolina. This training is useful as part of a study guide for technician certification. Be sure to watch for other study guides. This module has been converted from a PowerPoint presentation. Assessments and narration have been added by Technical Sales and Consulting's Training to Go format. If you have a similar format and need it converted, TS&C has the capability to convert it for you. For more information, visit tsnc.com/elearning. To examine training modules already developed to help with technician preparation training, please visit tsnc.com/pearl. Please take the time and register to receive your certificate of completion by clicking on the green box. After completing the short form, your certificate will be forwarded to you. If your browser does not support this operation, open a new tab in your browser and type https://tsandc.com/form. This URL will take you to the form. Thank you for completing this course.